The diagram shows a figure OABC where OA is defined as the vector A, OB is defined as the vector B, and OC is defined as the vector C. The lines AC and OB intersect at the point M, and this is important, where M is the midpoint of the line AC. So M is the midpoint here, and that's important for the first part of the question because it says find in terms of A and C the vector OM. Now, the fact that that's a midpoint means that if we did have a parallelogram here, such that this is also A and this is also C, then to get to here would be A plus C. Well, M would be the midpoint if that's a parallelogram. So OM is just going to be a half of A plus C. So I'm just going to take all these extra lines out because they don't need to be there. They're just there for explanation. Given that OM to MB is 2 to 3, find B in terms of A and C. So OM and MB is in the ratio 2 to 3. So in other words, this is 2/5 of OB, and this bit would be 3/5 over here. So what we're being told there is that OM is, and OM is this vector just here that we just found in part A. OM is actually 2/5 of the vector B, which is going all the way from O to B. So a half of A plus C is equal to 2/5 of B. So multiply both sides by 5. We've got 5 over 2. A plus C is equal to 2B. And therefore B is going to be 5 over 4 A plus C. Okay, so moving on. I think that the next part of the question doesn't refer back to this. Let's have a look. Yeah, so we've got vectors I and j are unit vectors parallel to the x-axis and the y-axis respectively, so the usual definitions of I and j. The vector p has a magnitude of 39 units and is in the same direction as negative 10i plus 24j. Find p in terms of I and j. Okay, so if we think about the magnitude of negative 10i plus 24j, we know we can use Pythagoras if we want to, but we also know that 5, 12, 13 is a Pythagorean triple, and this is just double that, so that one's going to be 26, and you could use Pythagoras to get that. Okay, and remember that 26 is equal to 2 times 13, and 39 is 3 times 13. So it looks like P is going to be 3 over 2 negative 10i plus 24j. Okay. We now want to find a vector q such that 2p plus q is parallel to the positive y-axis and has a magnitude of 12 units. Okay, so 2p plus q, so 2p's is going to be 3, negative 10, 24. I'm just going to go to column vectors here. I don't like writing all the i's and j's. And then q. And we know that that's going to have to be of the form 0, 12. It's got to have a 0i component because we're told it's going parallel to the j. As soon as it has any sort of I component, it's going to be at an angle. So it's got to have a 0 here. And for a magnitude of 12, this has got to be 12. So what we have is negative 30 and 72 plus q has got to be of the form 0, 12. Well, that tells me that q is equal to 30, so that we get a 0 component in the I, and it's going to have to be negative 60 just here. So let's write that in the form of the question. So we need to reintroduce the I and the j, like that. Probably get the right mark if we use the column vector, but I always like to put things in the form that the question was asked in. And then we want to show that mod q has the magnitude k root 5. So magnitude of q is going to be the square root of 30 squared plus 60 squared, which is, so we have got 30 squared add 60 squared, it's 4,500. And the fact that we've got a 5 in here gives us a bit of a clue as to what to do. So divide that by 5 and it's 900. So that's the square root of 900 times 5, which is root 900 root 5, and of course the root of 900 is 30. So 30 root 5.